Let's review for Chapter 10's exam. Question 1. A town's annual snowfall is normally distributed with a mean of 47 inches and a standard deviation of 6 inches. In what percentage of years is the snowfall between 35 and 47? Notice in this question we are mentioning the phrase normally distributed. That means I need to use a certain picture, and that's the picture for the normal rule. Let's put it here, and then we can do the problem. Now we know the mean is given. The mean is given. It is 47 inches. So put that in the middle of the chart, and we'll put that in the middle. The mean is 47 inches. The standard deviation is 6 inches. So the mean, which is mu, is 47. The standard deviation, which is sigma, is equal to 6 inches. What we need to do to 47 is subtract 6 from it, which is the standard deviation, mu minus sigma, and that gives me 41. We subtract 6 from it again. That gives me 35. And we subtract 6 from 35 again, and that gives us 29. On the right side, we could do the same process, but use addition. 47 plus 6, that's equal to 53. Plus 6 again, that's 59. Plus 6 again. The question is, what percentage of years is the snowfall between 35 and 47? We look at our numbers. Here's 35, and here's 47. To calculate our percentage, we just have to add up the areas between those numbers. We'll add up this area, and we'll add up this area. And if you look at the numbers, that's 34% plus 13.5%. 34% plus 13.5%, and that's equivalent to 47.5%. We know that the percentage of snowfall between 35 and 47 inches is 47.5%. Use this double bar graph to answer questions 2 and 3. The graph shows the number of males, M, and females, F, athletes at a university over a 4-year period. For question 2, in what year did we have the same number of male and female athletes? It appears to be in 2011. In the year 2011, we had the same number of male and female athletes. For question 3, what is the only year in which the number of female athletes declined from its previous value? We have an increase from 2009 to 2010. We have an increase from 2010 to 2011. But from 2011 and 2012, we had a decrease. So that means in 2012, that was the only year we had a decrease in the number of female athletes. Number 4, use the statistical display to answer the question. Which months differ the least in the number of licenses issued and by how much? Pause the video and try this question on your own. For question 4, there's actually 2 possible answers. If you look at it carefully, March and April, we have a difference of half a circle. And that difference is half of a circle, so that's half of 20,000 licenses, which is 10,000 licenses. March and April, we have a difference of 10,000 licenses. But if we look in May and in July, we had the same difference. In May and in July, we had the same difference, also 10,000 licenses. So for this question, we have 2 possible answers, March and April or May and July. Question 5, the amount of Jen's monthly phone bill is normally distributed with mean of $55 and a standard deviation of $9. within what range are 68% of her phone bills? Again, we're going to use that picture for the normal distribution. I know the middle is going to represent the mean, which is 55. And I'm going to subtract the standard deviation, which is 9 from 55. What's 55 minus 9? That's going to give me 46. And also, we're going to look at 55 plus 9, and that's 64. And I know, according to our chart, this is 34%, and this is 34%, which means the area between 46 and $64 in monthly phone bill is a total of 68%. So that's our solution. Between $46 and $64 is going to be 68% of her phone bills. Question 6. At one college, GPAs are normally distributed with a mean of 2.6 and a standard deviation of 0.6. What percentage of students at the college have a GPA below 3.2? For this, I will refer back to the picture again for the normal distribution. And let's put the mean. We know the mean. The mean is 2.6. And the standard deviation is 0.6. So let's fill out the chart on the bottom here. We'll add 0.6 each time as we go to the right, and then we'll subtract 0.6 each time we go to the left. And this should give me 3.2 here. Add 0.6 to it. I should get 3.8. Add 0.6 to that again, and I get 4.4. And on the left, I'll take 2.6 minus 0.6 from that. That gives me 2. Subtract 0.6 from 2, I have 1.4. And subtract 0.6 from 1.4, we get 0.8. Now the question in the problem was, what is the percentage of students with GPA less than 3.2? So we need to add up all of this area here on the left that's less than 3.2. Now you could do it the long way. You could add up all of these areas up, and that will get you the right answer. Or you could subtract these areas up from 100%. So there's multiple ways to do it. It's up to you how you want to do it. Here's how I'm going to do it. I'm going to take 100% and subtract what I don't want. I don't want this percentage, I don't want this percentage, and I don't want that percentage. So that's what I'm going to subtract from 100. I'm going to subtract 13.5%, going to subtract 2.35%, and I'm going to subtract 0.15%, and that should get me the total area here on the left that's below a GPA of 3.2. And that gives me a solution of 85%. So 85% of the students have a GPA less than 3.2. For question 7, Liz ran 32 miles, 11 miles, and 20 miles during 3 weeks. How many miles must she run the 4th week to give her an average of 20 miles per week? To do this question, recall the formula for the mean. The mean is the summation of all of our values divided by the number of values, which essentially means all I have to do to find the average is add up all of the numbers, including the 4th week, which we don't know. We'll call that x, and divide by the number of weeks, which is 4. So we'll divide by 4 because that's the total number of weeks. And we want the average here to be equal to 20. So let's have 20 equal to this expression. And so let's simplify it a bit. 32 plus 11 plus 20. This simplifies to 20 equals 63 plus x divided by 4. Now I could solve for x. Let's multiply both sides by 4. And that will reduce this, and 4 times 20 is 80, so we have 80 equals 63 plus x, and then I could solve for x. Let's subtract 63 from both sides, so x is equivalent to 17. So we need to run 17 miles in order to have an average of 20 miles for those 4 weeks. For question 8, what are the outliers given in this graph? The outliers is numbers that are far from the norm, and that looks like there's one outlier here, and that value is at 56. So there's only one outlier, and that's at 56. Question 9, what cluster has the highest scores? There's a small cluster right here with the highest scores. That's a score of 97 to 98. We have a small cluster there with the highest scores of 97 to 98. Question 10. In a school survey, students showed these preferences for instructional materials. About how many students would you expect to prefer written materials in a school of 450 students? Let's look at the chart for written material. That's 9%. We need to find 9% of 450. 9% in a decimal form is 0.09, and we need to multiply that with 450 to find 9% of 450. 9% of 450 is 40.5. So we expect about 41 students to prefer written materials in school. Question 11. The manager of an electrical supply store measured the diameters of the rolls of wire in the inventory. The diameters of the roll in meters are listed below. Compute the range. Recall the range is equivalent to the highest minus the lowest value in the data set. So which one's the highest? The highest is 0.656. So we have 0.656. And we're going to subtract the lowest value in the data set, which is this one, 0.115. And this gives us a range of 0.541 meters.